Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chippewa Engineering College. Today, we are going to discuss about some more examples in the Fourier transform and inverse Fourier transformation. Some of the examples we already seen in the previous classes. Some examples in the Fourier transformation and the inverse Fourier transformation. Today, also, we are going to discuss about some more examples in inverse Fourier transformation and the Fourier transformation. See, we already discussed about the Fourier series and the Fourier transformation. Fourier series is a trigonometric Fourier series, compact trigonometric Fourier series, exponential Fourier series. And in the exponential Fourier series, there is two formulas we have. One is analysis equation and the synthesis equation. By using the analysis equation, we prove all the Fourier series properties what we have in the Fourier transformation, the Fourier series also. And coming to the Fourier transformation, the Fourier transformation is also having properties. We prove that properties by using the definition of the Fourier transformation. If x of t be a signal which is a function of time t, the Fourier transformation of x of t is given as x of j omega or x of omega. X of omega is equal to minus infinite to infinite, x of t e power minus j omega t dt. Or in the normal frequency, x of if integral minus infinite to infinite x of t e power minus j. Instead of omega, you can keep it as 2 pi f into t dt. And coming to the inverse Fourier transformation, similarly, the x of t can be recovered from its Fourier transformation, x of j omega, by using the inverse Fourier transform. What is the inverse Fourier transform here? X of t is equal to 1 by 2 pi integral minus infinite to infinite x of j omega e power plus j omega into t d omega with respect to omega. Or otherwise, in x of I of f, x of t is equal to minus infinite to infinite x of if e power j 2 pi f into t dt. And this Fourier transformation, if it convert into the polar form, the magnitude of x of j omega into e power angle j omega, where x of here, the magnitude of x of j omega is the amplitude spectrum of x of t, and the angle x of j omega is the phase spectrum for a real valued signal. We already saying that there is some discrete conditions. One is a single valued property, finite discontinuities, and finite peak, and absolutely integrable. Okay, so the first one, the amplitude spectrum is a symmetric about the vertical axis, the even function, and phase spectrum is anti-symmetrical about vertical axis, odd function. So these are the existing of Fourier transformation discrete conditions. The function x of t should be single valued in any finite time interval t, and function x of t should have most finite number of discontinuities in any finite interval of t, and x of t should have finite number of maxima and minima in any finite time interval, and the function x of t should be absolutely integrable. So these conditions are sufficient but not necessary for the signal to be Fourier transformable. Okay, these are the conditions. Is sufficient, but it is not necessary. A physically realizable signal is always Fourier transformable. Thus, physical realizability is the sufficient condition for the existence of Fourier transform. All the energy signals are Fourier transformable. J d by dj of x of j omega is the Fourier transformation of t into x of t. And Fourier transformation of t into x of t is j into d by d omega of x of j omega. Okay, this is one of the property, time domain of the frequency domain, or frequency differentiation, time differentiation and the frequency differentiation. And we already seen this one of the example of the Fourier transformation, e power minus at mu of t is 1 by a plus j omega. Omega is nothing but 2 pi f. You can find out by using the rationalization the magnitude of x of f and the angle of x of f, tan inverse omega, and the magnitude of x of omega is 1 by under root of 1 plus omega square. Using these values, you can draw the magnitude spectrum and the phase spectrum. Okay. And this example is also we have seen already, the e power minus a, the magnitude of t. E power minus at is a t is greater than 0, and e power at is a t. It is a less than, my dear students, less than. It is not the greater than. So both are not the greater than. This is a less than. Okay. Whenever it is a less than means t values is a minus, and e power minus a into minus t is a plus e power t. Exponentially decaying, and here the exponentially rising function. And e power minus at mu of t, the 1 by a plus j omega, plus, and e power plus at is a 1 by a minus j omega. So both are you have to add to get the e power minus a, the magnitude of t. The Fourier transformation is 2a by a square plus omega square. And here also you can find out the magnitude and the phase. The magnitude is a 2 by 1 plus omega square, and angle is a 0. By taking off some values t from minus infinite to the plus infinite, the magnitude spectrum and the phase spectrum will get. Okay. And this also we already seen the x of t is equal to 1, the Fourier transformation of 1. By using the Fourier transformation definition, the discrete condition is not satisfied, but its Fourier transform can be calculated with the help of a duality property, because it is not absolutely integrable. Integral minus infinite to infinite e power minus j omega t dt, you get the infinite value. Not satisfies the one of the discrete condition. So with the help of duality property, the Fourier transformation of 1, you have to find out with the impulse Fourier transformation. Delta of t is a Fourier transformation is a 1. And x of t is a Fourier transformation of 2 pi into x of minus omega is the duality property. Using these two, you get the 1, the Fourier transformation is a 2 pi delta of minus omega. Actually, the impulse function is the impulse function, the even function. You can write as a delta of minus omega is also the plus omega. So x of omega is equal to 2 pi into delta of omega, and x of t is equal to 1. So 1 with the Fourier transformation is 2 pi delta of omega or minus omega. Because it is an even function, you can write it as minus or the plus. And similarly, this also we already seen the signum function, signum of t, 1 with the positive values and minus 1 is the negative values. And t is equal to positive, t is greater than 0, the magnitude is 1, t is less than 1, the magnitude is a minus 1. Okay. The d by dt using the x of t is equal to 2 mu of t minus 1. 2 mu of t minus 1 means the signum function we can represent it as in terms of step function 2 mu of t minus 1. Apply the derivative on both sides. D by dt, the 2 into d by dt of mu of t. The derivative of the step function is nothing but impulse function, my dear students. So d by dt of x of t is equal to 2 into delta of t. Apply the Fourier transformation on both sides. By using the one of the property, time differentiation property, d by dt of x of t, d by dt of x of t is j omega into x of omega, and delta of t Fourier transformation is 1. So I already multiplied with the 2. X of omega is equal to 2 by j omega. X of omega is equal to 2 by j omega. The signum of t, the Fourier transformation, is 2 by j omega. Otherwise, directly can find out 0 to infinite. 0 to infinite is a positive value. Minus infinite to 0, the magnitude is a plus minus 1. Okay. The signum of t is a 2 mu of t minus 1, and 2 mu of t is equal to 1 plus signum of t. See, using this formula, the x of omega is equal to, with the 0 to infinite, the positive value, and minus infinite to 0 is a minus 1 also. We get the 2 by j omega only. Understood, my students? And coming to the Fourier transformation of the mu of t, x of t is equal to mu of t, nothing but step function using the signum of t. We already know signum of t is equal to 2 mu of t minus 1. 2 mu of t is equal to 1 plus signum of t. Apply the Fourier transformation on both sides. 2 into Fourier transformation of mu of t is equal to Fourier transformation of 1 and Fourier transformation of signum of t. What is the Fourier transformation of 1? 2 pi into delta of omega. And signum of t is a 2 by j omega. So 2 mu of t, the Fourier transformation is 2 pi delta omega plus 2 pi j omega. Okay, the mu of t is equal to 1 by 2. Cross multiply this one, 2 by 2 here they get cancelled. And here also the 2 is there, 2 by 2 get cancelled, pi delta omega plus 1 by j omega. Okay, the Fourier transformation of 1, Fourier transformation of signum of t, Fourier transformation of mu of t, and Fourier transformation of double-sided e power minus a, the magnitude of t, and single-sided e power minus a t mu of t, or e power plus a t mu of minus t. We already seen these, all the Fourier transformation. And coming to the some of the properties we have here, it is a very important, my dear students. You have to note down all these properties. Any signal x of t with delta of t function, apply the integral minus infinite to infinite, you will get the same signal. Whatever is the x of t, the x of 0. Because why I wrote here the x of 0 means the delta of t is 1 at t is equal to 0 only. So the x of 0 value. And the x of t, any signal is multiplied with the shifted impulse function. Shifted impulse function, it is also equal to, it is not the same, my dear students, x of t naught delta of t minus t naught. Nothing is changed. Why? Here I wrote the x of t, but here I wrote the x of t naught. Why it is x of t naught? At t naught only the delta function. Suppose x of t having the 3 values like this. So minus 2, minus 1, 0, and 1. But what is the delta of t minus t naught? Delta of t minus t naught having only one value at t naught. That is also the one only. The remaining 0 is a 0, minus 1 is a 0, and minus 2 is also 0. So at t naught, let us t naught is equal to 1, x of t naught and the delta of t minus t naught. So x of t naught and delta of t minus t naught. Otherwise, if you can apply the integral on both sides, integral minus infinite on the both sides, if it is an integral on the left hand side, integral minus infinite to infinite x of t delta of t minus t naught into dt, you get only the signal x of t naught. X of t naught. See the x of t delta of t. Here the x of 0. Now it is shifted with the samples of t naught, so the 0 becomes of x of t naught. That t naught made either it is a 1, 2, or so on. Okay. Even if it is a 0 also, my dear student. Suppose if it is a 0, the same signal. Delta of t, x of t, delta of t minus 0. T minus 0 means delta of t on. So what is the t naught here? The 0. X of 0. So both are the same at t naught is equal to 0. Okay. Coming to the fourth one, scaling of the delta function. Delta of at is equal to 1 by a into delta of t. This is also one important property in the unit impulse. An integral minus infinite to infinite x of tau delta of t minus whatever it is a t minus alpha into dt, you get the same signal again. Okay, the x of t only. And another one is the delta of t related with the step function, the derivative. Impulse function is equal to the derivative of a step function, or step function is equal to integral of the derivative. Integral of impulse, integral impulse is equal to step. Integral step is equal to ramp. Okay. Derivative of ramp is equal to step, but derivative of step is equal to impulse. Following my students. That very, very important properties. Note down these all the properties and you have to remember this very useful in the online examinations. Okay, bitwise. And the Fourier transformation of the rectangular function. Fourier transformation of the rectangle function. We already seen this. So integral x of omega is equal to integral minus infinite to infinite x of t into e power minus j omega t dt. What is the x of t here? The magnitude is a 1 and it varies only in between of minus t by to the t by 2. So minus t by to the t by 2, x of t is a 1, e power minus j omega t dt. Apply the derivative here, apply the integral here. Upper limit you can substitute t by 2, lower limit is a minus t by 2. It becomes of 2 sine omega t by t. Convert this into the sinc function. Sine pi t, sine pi theta a by the pi theta is equal to sinc theta. Sinc theta. What is a theta here? You can see that it's a omega t by 2. Omega t by 2 here. Convert this into the sinc function. See, the sinc x is equal to sinc pi x by pi x. So using the sinc x is equal to 0 when x is equal to plus or minus n pi. See the pi, 2 pi, 3 pi, 4 pi, and so on. Okay, the sinc function is always a 0 when x is equal to plus or minus n pi. Plus or minus. Okay, for every the pi, the 2 pi, and so on. And this is a sine function, my dear students. Sine, and not the sine, is sinc only. The sinc is equal to 1 when x is equal to 0. So here the x is equal to 0, the sinc function is a 1. Sinc is equal to 1 when x is equal to 0 by using the L'Hospital rule. I already told this L'Hospital rule. Sine pi x by pi x. Apply the sine pi x is a cos pi x and is a pi. Cos pi is a 1. Okay, my dear student, it's a minus 3. It's a 1 value. So sinc x is a product of an oscillating signal sin x of the period 2 pi and decreasing the signal 1 by x. Therefore, the sinc is making sinusoidal of oscillations of a period 2 pi with amplitude decreasing continuously as 1 by x. See, the amplitude is also the decreasing magnitude, it's continuous. How it is? You see, you can sinc x is equal to sine pi x by x. Sinc 0 is equal to, sinc 0 means x is equal to 0. Sine 0 by 0 is an undefined value. By using the L'Hospital rule, the value is 1. L'Hospital rule, the value is 1, my dear students. And sinc 1 is equal to sine pi by the pi is a 0. Sinc 1 is equal to sinc x is equal to 1. And sinc minus 1 and the minus 2 is also 0. And sinc 2 is equal to 0. And sinc 1 by 4 is equal to 1 by 4 is equal to 0.1, 0.9, sinc 2 by 4, 3 by 4, 1.5, all these are values. So the sinc 1 is 0 here, sinc 2 is a 0, sinc minus 1 is a 0, sinc minus 2 is also 0. Alright, simply you can find, substitute that as a sinc x is equal to sine pi x by pi x. Understood, my dear students? Taking the values of x is equal to 1, 2, 3, 4 and so on, and the in-between values also gradually it decreases. 1 is a 0, 2 is a 0 and 3 is a 0, minus 1, minus 2, minus 3, minus 4 is a 0 values. And in between you can find out the values 1 by 4, 2 by 4, 3 by 4 and so on. It's gradually it decreases, and at 1 it goes to the 0, and gradually again it decreases and increasing, again goes to the 0 and so on. Okay, once you can use your calculator and find out all these values and see that that the sinc function is each value at 1, 2, minus 1, minus 2 is getting at the zeros or not, and the remaining values is also right. Okay, it is a very, very important, my dear students. Coming to the next one. And t into e power minus t to mu of t is also we already seen. E power minus t to mu of t is 1 by a plus j omega. When it is multiplied with the t, it becomes of 1 by a plus j omega whole square. Okay, 1 by a plus j omega whole square. And inverse Fourier transformation, these are the examples we already seen in the last class, in the Saturday's class. 2 j omega plus 1 by j omega plus 2 whole square by partial fraction expansion, and by using the convolution property, and the remaining is also by using the any one of the property, e power minus j minus magnitude of omega. We already know the e power minus a magnitude of et, how we can find. Now it is in the frequency domain. Okay. Then see another examples. We already seen these examples. I'm going to go for the another examples. The Fourier transformation. Find the Fourier transformation of the function mu of t plus 1 minus mu of t minus 1 into cos 2 pi into t. Cos 2 pi into t, my dear students. This is also already seen in the last class. How it is a Fourier transformation of 1? We know that 2 pi into delta of omega. Fourier transformation of e power j omega t, j omega naught t is a 2 pi into delta of omega minus omega naught. Okay, and Fourier transformation of cos 2 pi into t is a pi delta of omega minus 2 pi plus delta omega 2 plus pi. Okay, and using this, how one is a Fourier transformation is a, once again I am explaining this, one with the Fourier transformation is 2 pi delta of omega, and 1 by 2 the Fourier transformation is pi into delta of omega. Okay, if suppose if 1 by 2 is multiplied with e power j 2 pi into t, what is the Fourier transformation here? Whatever it is a 2 pi, the multiplication factor with the t is pi into, what is a plus is there, pi into delta of omega minus 2 pi. only the same thing here. Pi into delta omega minus 2 pi. Suppose it's a 1 by 2. Here I'm applying the Fourier transformation of 1 by 2 e power j 2 pi t. And for the second one, 1 by 2 e power minus j 2 pi into t. So what is the Fourier transformation of this function? Pi into delta of omega. Here the minus is there, now we get the plus 2 pi. Okay. Now we can add the two functions. The Fourier transformation of mu of t plus 1 minus mu of t minus 1, and Fourier transformation of cosine function, we got the pi delta of omega minus 2 pi and pi delta of omega plus 2 pi. Multiply these two. Fourier transformation of this one and the Fourier transformation using the modulation property. Okay, we already seen in the last class, that is in the Saturday's class, my dear students. Into the new, this one. It's a very good example. Determine the Fourier transformation of the triangular function. We already find out the rectangular function from minus t by to the t by 2. See, this is a rectangular function, my dear students. The rectangular function Fourier transformation. Now the triangular function. So this is a triangular function. First of all, find the slope of this minus t to the a and the slope equation of the a to t. The magnitude is at a for both the minus t and the minus t to the t. At 0, the magnitude is a 1. At minus t, the value is a 0 of x of t, and plus t is also at t is equal to capital T, the x of t is a 0, and gradually it is decreasing from 0 to t, and gradually it is increasing from minus t to the 0 value. Okay, my dear students. Now see, what are the quadrants here for the triangular wave? Minus t, 0. Minus t, 0. Any point on the real axis means imaginary value is a 0. So x and y. Okay, minus t, 0. And here also x and y. What is the y here? The y is a 0. T comma 0. And coming to the y-axis, nothing but is the x of t signal. The point on the y-axis means x is a 0. 0 comma a. These are the three quadrants we have for the given triangular function. Carefully listen, my dear students. These are the examples definitely you'll get in the external examinations. The triangular wave and the rectangular wave and sine function. Okay, cosine functions like that. How you can find the slope of this function? Okay, slope. What is the slope equation? Y is equal to mx plus c. Listen carefully, my dear students. Once again, I am saying mx plus c. Okay, forget about the c. Is a straight line equation. You have to find out the slope here. Now, I am taking the y as a y minus y1 is equal to m is y2 minus y1 whole divided by x2 minus x1 as a slope whole multiplied with x minus x1. The straight line equation, my dear students, with the slope. Now I am taking the a slope. Okay, slope a. Okay, my dear students. Taking the quadrants are x1, y1, x1, y1, the minus t, 0, and x2, y2, is a and 0, a comma 0. Okay, my dear friends. Now I can substitute in this equation to get the slope of slope a. Okay, y. What is the y here? In the y-axis, the signal is x of t, my dear friends. So x of t minus, what is the y1? Y1 is a 0. 0 is equal to, what is the y2 here? Y2 is also 0. 0 minus y1. You see the y1 is a 0 here. 0 minus 0. Okay, it is not the y2 minus y1. See, this is not the x1, x2 here. Y1, y2. Sorry. This x1, x2, my dear students. It's not a y1 and y2. y1, y2. Okay, now we get got that in the y-axis and it is in the x-axis. X of t, what is a y1? Y1 is a y minus y1. Y1 is a and 0, my dear students, not the a0. Here also you did some wrong. 0 comma I, not the a comma 0. So y1 is also the 0 and y2 is a minus y1 is a 0 whole divided by x2 is a 0 minus x1. What is x1? Minus t, and x, what is the x here? X is nothing but the t variables only. T minus x1. What is the x1? Minus t. Okay, my dear friends. Now the x of t minus 0 value, a minus of minus is a plus a by t whole multiplied with the t minus of minus is a plus t plus capital T. T plus capital T minus. Okay, students. Any confusion here? X of t as a y because the x of t signal is in the y-axis and y1 is a 0 here. Y1 and the y2 a and y1 is again 0, the a minus 0 and 0, x2 is a 0 here and x1 is a minus t, minus of minus t, and this is the t. Why I wrote the t? Because x-axis the variable is a t only, t minus of x1. What is the x1 here? The minus t, minus of minus t. So the x of t is equal to a by t, the t capital T, t plus capital T. Now multiply this function, a t by t plus, and t get cancelled, it is a only. And again that is take the carbon as a small t by the capital T plus 1. X of t is equal to, okay, this is a slope. See, we got the same thing. Equation of the line equation, the slope is a by t. Okay, and the line equation is x of t is equal to a into t small t by the capital T plus 1. Okay, similarly you can find not the straight line equation with slope, not the, is also wrong, my dear students. Line equation, this is a line equation. because I substitute the y minus y1 and x minus x1 also. And come to the line equation of the b. What are the quadrants here? x1, x2 is equal to, in the x-axis, see the t comma 0, my dear students, t comma 0. And y1, y2, the same thing, y1, y2, 0 comma a, 0 comma a. Now the straight line equation is the same, y minus y1. So y is x of t, y1 is a 0, is equal to y2 minus y1. y2 is a, y1 is a 0, x2 is a 0, minus x1 is equal to plus t now. T whole multiply with x minus x1. What is the x here? The t. T minus x1. What is the x1? The t. So x of t is equal to a by minus t, that is capital, and t minus t. Multiply this function minus at by the t, capital T. Already the minus into minus is a plus. Capital T get cancelled. A. Take the common of a here. I'm taking the minus a. A can take the common, or a plus a only. 1 minus t by the capital T. X of t is equal to. Okay, my dear. See, here also the same thing. A into 1 minus t by t. The equations, the line equation of A and the line equation of B, we got by using the straight line equation, mx plus c, y is equal to mx plus c. Okay, my dear students, how we got this A t by capital T plus 1, A into 1 minus t by 2, t by the capital T. Okay. Now using these two equations, so we got the line equation of A and the line equation of B, my dear students. So mathematically we can write as x of t as x of t is equal to A into t plus t by capital T plus 1 mu of t plus t minus mu of t. How we got this equation? And for the second one, A into 1 minus t by t, the mu of t minus t. We got these two equations, A into 1 minus t by t and A into 1 plus t by t. And what is the equation of this? Mu of t plus capital T minus mu of t. Okay, my dear students, how we got that function? Let us see by using the graphical representation. Mu of t. How we can write this mu of t? Mu of t from 0 to the infinite with the variables of the t. Okay, mu of t plus t. Plus t. Plus t means it is shifted towards left side with the t samples. With the t samples, my dear students, because it's advanced signal. Mu of t plus capital T 0, and here the value is a t. Okay, my dear students. Now, these two here we can subtract the mu of t plus t minus mu of t. Subtract these two functions. I'm taking the first of all the mu of t plus capital T. Listen carefully, my dear students. So this is a graphical representation is very, very important. How we got this expression by given the rectangular, not the rectangle, triangular function. Converting into the mathematical expression by the triangular function. Okay. T plus capital T minus mu of t. See, from the t to 0, observe here. Here also the t. This is also the t here. What is the value of mu of t from t to 0? 0. But here, the magnitude is 1, and here the magnitude is also 1. Okay. Mu of t plus t, the value is 1 from t to 0. Minus 0. Minus 0 means up to the t to 0, the value is 1. We are subtracting these two. We are subtracting from mu of t plus t minus mu of t. Here the 0 and this 1. 1 minus 0, 1 only. Coming into the 0 to infinite, 0 to infinite, mu of t plus t is 1. Mu of t is also 1. So 1 minus 1 is 0. 1 minus 1 is a 0. Now see, this we can call it as a gated function. From t to 0 only the value is 1, the remaining all the functions, even from the minus infinite to the t and 0 to infinite is both, all the values is a 0. And this function is multiplied with x of t is a into t by the t plus 1 or 1 plus t by t. A into 1 plus t by t. See here, for a into 1 plus t by t, the slope equation multiplied with the unit step function by subtracting the mu of t plus capital T minus mu of t. Coming to the second one, I hope everybody can understand this graphical representation, the mathematical expression, my dear students. Coming to the next one, mu of t minus, why it is a minus here? Again, I'm drawing the mu of t. Mu of t is a step function with a magnitude of 1 from 0 to infinite with the t variables. And what we taken here, the mu of t minus t. Previously it is a mu of t plus t. Minus means a delay function with the t samples. With the t samples. So mu of t minus t. Okay. Now these two I can subtract mu of t minus mu of t minus t. Previously we are subtracting the mu of t plus t to the mu of minus t. Now it is a mu of t minus mu of t minus t. So minus infinite is 0 and here the minus infinite is 0, the value is a 0 only. Okay. Now coming here, mu of t is 1 and mu of t minus t is a 0 from 0 to t. Observe here, up to the t, mu of t is 1 and this is a 0. 1 minus 0, 1. And from t to infinite and t to infinite here, the 1 minus 1 is a 0. Okay. From minus infinite to the 0, the value is a 0. And having only 1 in between of the 0 to t. In between of the 0 to t, my dear students. And remaining the value is a 0 here. So slope is also in the 0 to t only. 0 to t. And in the previously, slope is there in the minus t to 0. Okay. For this, we are multiplying the mu of t minus mu of t minus t to the slope of the line equation. The line equation or the equation of the line of B a into 1 minus t by the t. A into 1 minus t by t, my dear students. Okay. Now the mathematical expression we got for the given triangular function in terms of their line equations and the step function. Understood? The x of t is equal to multiply a by the t, a by the t, t plus t, mu of t plus t minus mu of t. Why I am taking the t in the outside and the multiply the t is there. Here the 1 a by t is taking this as a common term, t plus capital T and the same function, and here also the take the t as a common term, capital T minus t mu of t, and rewrite this expression a by t multiplying the t plus capital T with the mu of t plus t minus t plus capital T, the multiplication of mu of t, plus the second term a by t is a common, capital T minus t into mu of t, and capital T minus t is multiplied with the mu of t minus t. Okay, and this again you can rewrite the expression. Okay, I will explain. A by the t, t plus capital T. Okay, my dear students, and it is multiplied with the mu of t plus t minus mu of t. I'm writing only the first one, first term. This is okay. Keep it the a by t is a common term. Multiply this t by t with these two functions, t plus capital T into mu of t plus t minus t plus t whole multiplied with the mu of t. Okay, my dear students. And again, rewrite this expression as a by t, t plus capital T whole multiplied with the mu of t plus t. Now I'm writing this as a two functions, t with mu of t and capital T with mu of t, minus t mu of t, because here the minus the capital T is there, minus capital T mu of t. Okay. So finally we got this one. See the a by t, t plus t mu of t, t plus t the mu of t, and the next one is there the t with the mu of t as a minus, capital T the mu of t. Okay. Why they wrote it is a f mu of t plus t. The mu of t plus t can write as here the r. Why the r of t plus t? Why it is r of t plus t means t with the mu of t. T with the mu of t is nothing but it is a ramp function only, my dear students. Ramp function with advanced signal, the t variables. The t variables. Alright. And this function, as we know, the ramp function is r of t is equal to t into mu of t. R of t is equal to t into mu of t. We know why it is a mu of t is multiplied with the t signal means a ramp function is a linear function. At 0 is equal to 0, t is equal to 0, r of t is also 0. Okay, what is it? 1, the r of t is also 1. And 2, r of t is also 2. And 3, the r of t is also 3. Why it is a multiplied with the mu of t means we are taking the values only from the 0 to infinite. We are not taking the values from the minus infinite to 0. So multiplied with the step function, r of t is a t into mu of t. But here, instead of t, that is a plus is there. Plus with the samples of t. So t is replaced with t plus capital T, r of t plus t is equal to, and t is t plus capital T and mu t plus capital T. Okay, my dear students. So t plus capital T mu of t plus capital T is equal to, what is the equation here? R of t plus t. So a by the t, and this total function is r of t plus t minus, you see here, t into mu of t minus capital T into mu of t. Okay, my dear students. This is the equation we got. And see here the t into mu of t also. We already know the t into mu of t is again r of t. So it is rewrite as a by t is a function of r of t plus t plus, not the plus, my dear students, is a minus t into mu of t is r of t only. R of t minus capital T into mu of t is a final equation. A by t into r of t plus t minus r of t minus capital T into mu of t. That is the first term. For the second term also, you can see here, the second term, I'm taking the second term, a by t, t minus small t. You see from this equation, I brought that is a t as a common, then it is a multiplied with the t and minus small t. Okay. Whole multiplied with mu of t minus mu of t minus t. Okay, my dear students. Now, keep the a by t is common to all the terms. Multiply this t minus small t with the mu of t. Similarly, the t minus t with the mu of t minus t. Okay. Again, the a by t. Here the two terms you can write as t into mu of t minus t into mu of t, and I'm taking the minus as a common, plus it becomes of t minus t, small t minus t, my dear students, small t minus capital T. So mu of t minus t. Why I take the common means in the parenthesis of the step function there is a t minus t. Here also you get it is a t minus t. Take the minus as a common, it becomes of plus t minus t. Okay. Now, is a by t. T is a small capital letter only, the t mu of t minus, we know that t into mu of t is r of t, my dear students. R of t plus, here also the t into mu of t, but instead of t, that is r t minus capital T. So r of t minus small t, not the t minus capital T. Is the equation C here? Final equation C, the a by t, the t into mu of t minus r of t, and r of t minus capital T. Like that, we got the two equations. In these two equations also, again you can simplify these two, a by t, r of t plus t. There is no any r of t plus t. The same thing, a by t, r of t plus t, and a by t minus r of t, a by t minus r of t, my students. So minus r of t minus r of t is a minus 2 r of t. A by t is a common. And another one, a by t r of t minus t. And here the minus t mu of t and the plus t mu of t, both are get cancelled. And finally we have only the three terms. One is r of t plus capital T, and r of t minus capital T, and minus r of t minus r of t is a minus 2 r of t. Okay, my dear students. Now we can apply the Fourier transformation on both sides. Fourier transformation on both sides. Okay. What is the Fourier transformation of the ramp function? Fourier transformation of the ramp function. T mu of t. T mu of t, my dear students. Okay. Whenever the t is multiplied for any function of the Fourier transformation, it is a square. It is a square. We already know. E power minus at mu of t. What is the e power minus at mu of t? The Fourier transformation. 1 by a plus j omega. And now it is multiplied with the t to the e power minus at mu of t. What is the Fourier transformation? Square of this one. 1 by a plus j omega whole square. What? First of all, you can see what is the Fourier transformation of mu of t. Fourier transformation of mu of t is a 1 by j omega. Mu of t, the Fourier transformation is 1 by j omega. And now it is a t mu of t is, what is the Fourier transformation? Not the Fourier transformation, square 1 by j omega whole square. See here, there is a 2 multiplied minus 2, the r of t is 1 by j omega whole square. 1 by j omega whole square. Okay, and the remaining two functions, it is also the r of t, it is also the r of t. See, in the denominator 1 by j omega whole square, 1 by j omega whole square. But there is a multiplication factor of e power j omega t plus for the first one. For the second one, the e power minus j omega t, third factor, third term, e power minus j omega t. Why they got? By using the shifting property. What is the shifting property saying? X of t minus t naught. X of t minus t naught. What is the Fourier transformation? Fourier transformation is e power minus j omega t naught into x of omega. See, what is x of t here? Ramp function. For the ramp, x of omega is 1 by j omega whole square, and it is shifted with the samples of t naught. Shifted with the t naught samples means multiplying the exponential function, e power minus j omega t naught. Same thing, now I am taking here the r of t. Fourier transformation is r of t Fourier transformation is 1 by j omega whole square. Now it is shifted with r of t minus t capital T is a Fourier transformation of is x of omega. 1 by j omega whole square is x of omega. It is multiplied with e power minus j omega into